Hello, and welcome to our last lesson in our short first unit, Functions and Function Families Overview. We're going to go through this in a little bit more detail, so forgive me if the video is long. Just remember that this would take 90 minutes in class where we kept stopping and everything. So going through the video in about 30, we could have an announcement also.
Your cap and gown distribution is now complete. If you have your items, please exit campus. We need you to take your
All right.
items
I'm obviously recording this in the spring during senior cap and gown distribution.
Unless you have been told otherwise by Ms. Solomon face to face. If you are needing to still pick up a cap and gown,
I'll pause this maybe.
Between 8 and 9 a.m.
Okay, I'm sorry about that. It is spring, and cap and gown distribution for seniors was this afternoon, and sorry about that. It just ended. All right, so without further ado, that was more than enough ado for the start of a video. Let's go into the concepts for this lesson. I really think that functions are hit on in Algebra 1, but not really done in detail. And in fact, I had a class in here. It wasn't my class. It was another teacher's class. And I asked them, if you could define what a function is, how would you define it? And I got some interesting answers. So we're going to start by talking about relationships. And I realized my arrows are not, my arrows, I didn't zoom my arrows in. So look at the sets of numbers below and decide what the relationship between the first set, which we'll call X, and the second set it is. So looking at this first one, all right, so we have a set of numbers. Now, set is another math term. There's so much math vocabulary that goes into actually talking about functions really well. But a set is just simply a collection of things. So if you have a set of baseball cards or a set of, I don't know what you might collect, keychains, a set of strawberry shortcake dolls, okay? Those were a big thing when I was a kid. So in math, though, when we talk about a set, we're usually talking about a set of numbers. And in this case, my set of numbers X is -3, -1, 0.25, 2, and 3.5. And then we have the set of numbers on the right, which is our Y values, and that set of numbers is -12, -4, 1, 8, and 14. And then the arrows indicate how those numbers are related to each other. So a -3 for the X would go with or pair with a -12 for the Y. -1 for the X pairs with a -4. So take a moment and pause the video if you need to, and I want you to think about what is the relationship between the set of numbers X and the set of numbers Y. Okay, and the way we might write this out is we would say, well, Y is equal to, okay, so Y is equal to, and you might have come up with this, not that though, not that, hopefully you did not come up with that. You might have described it in words. You might have said, well, if you take X and you multiply it by 4, you would get your Y value, which would be the case. And so you could say Y is equal to, I'm still not doing that right. It is equal to X times 4. Okay, except we wouldn't write it that way. Usually we would write it as Y is equal to, instead of X times 4, we would say 4X. Now I am going to pause here briefly and just say, when you see some number and then a letter, that is multiplication. So that is 4 times X. That is something that has cropped up in recent years where I've asked students, what is the operation between the coefficient? The coefficient is just a very long word that is the number in front of the letter, and the variable, and have been told all kinds of things, and sometimes have been told just, I don't know. So that is multiplication. If you see 4 times X or 4X, that is times X. So we have there what essentially amounts to like a table. It's actually called a map. And then we have the equation form. So let's take a look at the next one. So this one looks a little different. And pause the video if you need to and see if you can come up with a way of describing the relationship between the x's and the y's. Okay, this one is tricky, and it's tricky for a reason. So when I put this up here, instead of saying y equals, which you're probably used to, and that is a reason, there's a reason for why you're used to seeing y equals, this one actually says x equals. So it's almost like you're working in the backwards order, but it actually lends itself to a more natural equation. 4 is going with the -2 and the 2. And so if you square a -2, so multiply it by itself, -2 times -2, that would give you a 4. And if you square a 2, 2 times 2, that would also give you a 4. If you look at the 1 here, if you see that maps to 1 and -1. And so if you square a -1, you get -1 times -1, which is +1, and 1 times 1, which is 1. And then 0 maps to 0. So if you squared 0, 0 times 0 is 0. And so this actually is a little bit more natural to say x is equal to y squared. Now you could do what is called solving that for y, and that involves taking the square root of both sides, but it's a little bit less natural way. Now the point of this is to just talk about the relationships between numbers. So let's go into that in a little bit more detail. In math, we study all sorts of relations. You do not need to write this down. This is more background. So in math, we study all sorts of relations. We are interested in the patterns relating one set of numbers to another because these patterns model and predict what happens in the world around us. Some patterns are really common and some are not as common. So there are certain types of relationships that we see all the time. And if we wanted to write word problems and application problems, we have all different kinds of real life scenarios where we could pull those relationships. Other ones are just not as common. And so you might study them in a math class, and it's actually kind of hard to come up with a great application problem for it because it's not a really common relationship. It's not that it never comes up or that the math doesn't describe something real. It's just, it's not as common. The higher you get up in math, the more obscure stuff you kind of start to study. So why is this important for Algebra 2? Algebra 2 is structured around studying specific relationships between numbers. Particularly, we study relationships that qualify as functions. Okay, and so I want to really start out with that broader relationships between groups of numbers. So you can have a relationship where you're multiplying, or a relationship where you're adding or subtracting, dividing, and doing a whole lot of other things that we haven't even studied yet. In Algebra 2, we structured the entire course around studying specific kinds of relationships. And we get to the end of this presentation in another bajillion minutes or so. I'm actually going to take you through the outline of the course as it exists in its current form, so that you can see how this plays out. So what are functions? Oh my word. Okay, so I'm going to give you a definition of a function, but then I really want to unpack that definition. All right. So a function is a relation. So first up, a function is a relation or a relationship. Usually in math, we will say relation instead of relationship, but you could probably use either one. So it's a specific kind of relation. We just said relations have to do with patterns between numbers, but it's a specific kind of relation that's going to meet certain requirements. And here are the requirements. In which each x maps to at most one y value. Okay, so every number in that first set of numbers, when you look to see how it maps out, it maps to at most one y. Now, the reason we say at most one is because, this gets into some dicey math, like vocabulary with is something in the domain, if like, you know what, I just don't even want to go there. Okay, at most one y value. We're just going to leave it there. Now, alternately, you could phrase it this way. Each element of the domain maps to at most one element in the range. Now, if I were to give you that definition, you might say, okay, great, I can write that down and maybe I can even memorize it, but I have no idea what you just said, Ms. Taylor. That's probably because there's some vocab in there that you are unfamiliar with or uncomfortable with, and that vocab is domain and range. The domain is simply the set of x's. So it's basically that first group of numbers. It's the group of numbers that you're starting from. And the range is the set of y's. And I'm going to put another vocab word in there that's going to prep you for pre-cal. The x's are called the inputs, the n in inputs, and the y's are called the outputs. Okay, so you have inputs and outputs. In other words, this is what I put in, this is what I get out. And how you get your output has to do with whether you're adding, subtracting, multiplying, dividing, and all of that. So when you hear domain, domain is just the word that describes the set of x's or the things that go in. That input-output is going to make a little bit more sense before we get to the end of the lesson. We're going to look at functions a slightly different way. And then range, you want to think those are my sets of y's, and we have another.
This is the last call. If you have not made it to the auditorium, you are not going to be allowed to pick up your capping gown today. This is the final call for capping gowns. Again, if you have not made it to the auditorium in the next minute, you will not be able to.
Okay, don't play games if you're a senior with your capping gown distribution.
Again, final call for capping gown. You have about 45 seconds now.
All right, now we have three main ways that we can display functions, and all three of them are important. All three of them have advantages and disadvantages. I would say two of them we use more than the third one, but okay. So one of the ways that we display functions is with an equation, and that's one of the common ways that we display functions. Okay, so we can use equations. The other really, really common way is with graphs. Okay, and in an earlier lesson, we actually spent quite a bit of time going from linear equations. Okay, so you have y equals 2x plus 3, and how you go to do a graph. And the middle step that we took was the third way, which is tables. And so what we did when we were graphing lines in a couple lessons back, we had maybe say y equals 2x plus 1, and what we did was we built a table, and then after we built a table, we constructed the graph. And so we were going through all three of them. Again, all three of them have their advantages and disadvantages, what they're good for, what they're not as good for. I would say we use equations and graphs the most and tables the least, but that does not mean that tables are not important or don't have their place in algebra. The better you are at math, the better you're able to go back and forth between those different ways of representing our functions, and the better you are at picking the right representation for the problem you need to do. And that can come in super handy, because if you're not that great at equations, but you are pretty good at graphing and Desmos, and you can do some stuff there, you can actually answer a lot of questions and get a lot of insight by using a different representation. All right, so let's go back to our intro example. Which of these is a function and which is not? And then the important part is, how do you know? It's not as important that you get a yes or a no. Yes, this is a function, or no, it's not. Like, yes, I want you to have the answer written down. But what's more important is, do you know how to get there? Because like on the next slide, I'm going to show you something different that you haven't seen before. All right. So when you're determining whether something is a function, what you want to look for is in your x's, okay, your inputs. You want to make sure that each input is going to just one output. Now, it's totally okay if two inputs go to the same output, as long as that input is not going to more than one. Over here, so this one is a function. And the reason it's a function is because each x value, or each input, has only one y value that goes with it, or only one output. If you come over here to this one, you will notice that one x value actually is going to two different y values. In other words, one input has more than one output, and that is not okay. In fact, it happens twice. Okay, where you have an x and it goes with more than one y, and that disqualifies it from being a function. That is not a function. So when you're looking at this, this is actually, and if the announcement hadn't come on, I probably would have remembered to say this. This representation is called a map. Okay, it's another way of representing functions. It's just not very common at all. Usually the only time we do maps is when we're doing this, and then we don't look at them for the entire rest of the year. So we're working with maps right now. So we have yes and then no. So you try. Is this a function? Go back to the definition before you answer. Don't just look at it and get freaked out by something or alarmed by something and then answer. Pause the video if you need to. All right. This one is a function. And how do I know? Because each of my x's is only going to one y. Now, you might say, but wait a minute, Miss Taylor. Up here, both the -5 and the +5 go to a 0. That's okay. Okay, it is okay if two inputs have the same output. What's not okay is if you have one input going to more than one output. So it's like one of those is okay and one of them is not. Sometimes when I've taught this, I've taught it as like an illustration. If this is the class over here and the bell rings, okay, and this is your next class, all right, is it possible for two of you to go from this class to the same class next period? Well, yes, that's completely possible. In fact, it's likely that there are a couple of you in any given class that you're actually going to go to the next class together. What's not possible is if one person tries to go to two different classes. So if you get a schedule in August and it says period 2 algebra and period 2 Spanish, you've got a problem. You've got to go get a schedule correction, because you might be good, but unless you have a Harry Potter time turner that you can go to more than one class at the same time and just rewind, yeah, it's not going to work. And so this way is okay. Okay, this is totally okay, but the other way is not. So yes, this is a function. If you got it wrong, what I want you to do is pause the video and make a couple notes, maybe write down, the illustration of here's the class and there's your next class, the students in the class, and so forth. Oh, that was me not paying attention. So the relation is a function because each x maps to only one y. So if you were asked to explain in words, is this a function? That is probably one of the ways you do it. You could also say because each input maps to only one output. That would also be okay. So each input maps to only one output. All right, so let's look at how functions compare with non-functions when we graph them. So we're going to go from these maps and the idea of the mapping to what does this look like when we have a graph. So this one is a function. I know it is a function because when I look at each of my x's is only going to one place. Now, it's true that we have some overlap in where they're going, but that's okay. So let's go ahead and plot these. So -3 maps with a 10. So I would go -3 on the x-axis and then up to 10. So there's 1. -2 is mapping to a 5. -1 is mapping to a 2. 0 maps to a 1. 1 also maps to 2. 2 is going to map to 5. and 3 is going to map to 10. Now, what I want you to notice is that there is most definitely a pattern here. Okay, this is not just a scatter plot. It could be a scatter plot. And I want you to look real closely at how these line up. Now, what you might want to do, I will not be able to do it because when I'm recording a PowerPoint, you cannot go backwards in your slides. But you'll be able to rewind the video and come back and look at this one again. So take a good look at that. That is what it looks like when you have a function. So each x value, as we go across here, each x value has at most one y value that goes with it. And so like the 3 only goes to one location. The 2 only goes to one location. All right, so that's what a function looks like. Let's look at this one. This one is not a function, and I know it is not a function because I have one x value that is going to 2 different y values. So let's go ahead and plot this one. We have -2, 3. I don't think this one has a pattern. -1 and -1 goes to 4 and also goes to -1. 0 goes to 1 and 1 goes to 1. All right. Now what I want you to notice is the violation part here. This is the part that violates it being a function. Okay, a function is each input can only go to one output. Here's what it looks like. Here's what the violation looks like on the coordinate plane. It looks like 2 points that are stacked up over each other. And that's because the number 1 for the x has 2 different y values that go with it. And so where we had the function, each x only went to one y. When you have a non-function or something that is not a function, you have an x value, and that x value goes to more than one y. Now, on the map, it looks like kind of like a splitting at the beginning. On the graph, what that looks like is 2 points that are stacked up. So that leads us to our key idea. It's something called the vertical line test, which I will often abbreviate VLT because I don't want to keep writing that out in class. So the vertical line test tells us if a relation is a function by looking at the graph. And it's one of the easiest ways to tell if something is a function is to graph it and go ahead and look at the graph. So here's essentially the vertical line test. If one x maps to more than one y, the points will be stacked vertically on the graph, which is what we just saw. So the points actually end up on top of each other. So you have one high up and another point underneath it. That's okay. If one, then the points will be stacked vertically on the graph. If you see any point stacked, then the relation is not a function. Okay. So when you're looking at the graph, if you see any place on that graph, even just one place where 2 points are on top of each other, okay, what that means is that you have an x value that is mapping to more than one y value, and it is not a function. So usually when we're talking about the vertical line test, I guess we could talk about it passes the vertical line test, but a lot of times what we're looking for is we're looking for a point of failure. So often we depict this as a vertical line, hence the name of the test, that slides across the graph. If that line sorry, I hate typos. And the problem is by the time I teach this in the fall, I'm probably not going to remember that I had these in here. If the line ever goes through 2 points of the graph at one time, it is not a function. And so we grab like our ruler, our finger, our meter stick, and we slide it across the graph. And we're just looking to see, is there any point where this particular relation fails the test? If you get all the way across your graph and it doesn't fail, then it passed the test and it is a function. If it does cross more than 1 point at a time, then it fails the test. Essentially, the vertical line test is checking for those stacked points. So which of the following are functions? Looking at this, okay, and there's no tool on this where I can like slide a vertical line across it. So essentially you'd be doing this. You'd like kind of slide the vertical line, okay? And what you're looking for is, does it ever cross more than once? And only crosses once. And you can do this, most students do this in their head. They just kind of go across and yes, this is a function because it passed the test. I never had any stacked points. Okay, here's another one. And you slide your vertical line, and we're looking to see, does it ever cross more than once? Nope, crosses once. We're looking for points that are stacked on top of each other, and I don't see any. So yes, that is a function. So at this point, you might be wondering, all right, you got to show me one that's not a function. Well, here we go. Not a function. Because if I put a vertical line through that graph, here are my stacked points. Okay, I've got some points that are stacked on top of each other, which means that I have one x that is mapping to more than one y. So that is not a function. Okay, this is a circle. Are there equations for circles? Absolutely. You might be seeing one later in this lesson. Okay, is a circle a function though? Nope. There's my stacked points. Okay, and you only need one pair of stacked points, okay, for it to not be a function. You don't need to have it all over the place. Just one, and it's not a function. So not a function. This is actually something that we don't study in this class. This would be like some kind of sine wave. And this one is, now I am aware that when I drew this using suboptimal tools, it does look like it's vertical right there, but it's not supposed to. All right, and so everywhere I go, it appears to be a function. In this class, we're going to study these first two. We're going to spend quite a bit of time looking at stuff like this. We studied this a little bit. We're actually only going to look at it in this lesson. We do not study this. This would be saved for your pre-calculus, okay? But sometimes you do. Like you can do a little bit of that in Algebra 2 sometimes. This equations of circles, I studied circles also in Algebra 2, but they are not in our curriculum like here in this county. All right. Next little piece of information is something called function notation. And this I'm reasonably sure that most of you have seen before. That doesn't mean that you like it, but so function notation looks like this. Okay, and it's got usually the letter F, but you might see, say, the letter G or H. Okay, you could see, say, like P, or you could see like a name. I had a graduate professor that would name his functions Bubba. Okay, now that is that's our function notation. This that you see out front is simply the name of the function, and this indicates your inputs or your variables. Okay, so it means that the function name is F. It's F because the word function starts with F. Literally, that's it. Okay, there's no other rhyme or reason to it. And then the in parentheses is what your inputs are. And the way you would read that out loud is you would say F of X. Okay, that is how that expression is read out loud, F of X. Now, other names for functions that you will often see in algebra classes are G and H because they come after F in the alphabet. So A, B, C, D, E, F, G, H. Okay, and that's it. You might see other letters in word problems. So if you saw P of X, it could mean profit. Okay, so the profit function. But like I said, I had a graduate professor who would name his functions Bubba, which is a Bubba of X. Okay, because all it is the name of the function. So it could be profit, but most of the problems we do are not word problems, so we don't have a name or a word we want to put in there, so we just call them F, G, and H. Now, what does it mean? It means that Actually, what it means is that the particular relationship you're dealing with is a function, but it means that f is a function of, well, yeah, I'll put that up there, function of x, or you might be more comfortable with f depends on x. Okay, so f depends on x, or f is a function of x. It just means that you have a dependent and independent variable, and those are your inputs or your outputs. Your output depends on your input. What you get out of the function is determined by what you put in the function, and your x's are your inputs. It is often used in place of y. Okay, so you might have had a teacher just say, oh, something like this. They might have just said, oh, f of x is the same as y. Well, not really, and I hope this lesson kind of cleared that up. But it's used in place of y. And what it does is it tells us both the x and the y value. So if you had something like f of 5 is equal to 3, what that expression tells you is that your x value is equal to 5 and your y value is equal to 3. Or that the 0.53 is on the graph. So it does have a bit of an advantage over just using x's and y's, because it does tell you both the input and the output. So it tells you when the input x is 5, the output that goes with it, or the other side of the mapping, is going to be a 3, as opposed to just saying y equals 3, which doesn't tell you when y is equal to 3. It just, I guess, at some point y is equal to 3. Now, to be fair, function notation does take some students quite a while to get comfortable with. It feels very awkward and uncomfortable. I did not see function notation at all until I took Algebra 2, and I did not like it. I did not understand why it was important, or why I needed to do something when x and y just seemed like they worked fine, and it just felt like we were complicating stuff. And I totally understand if you feel that same way. It is very useful. It absolutely has a place in math, but give yourself some time to just get used to it. And it's totally okay if you feel awkward with function notation, even throughout most of the year. It's okay if you feel awkward about it. So evaluating simply means find the numerical value of. So when you're asked to evaluate something, you're being asked to find the number value. So if you have f of x, notice how I'm reading that, f of x is equal to negative 2x plus 5, then, and we're asked to find f of 1, this means find y when x is equal to 1, and you use the equation to do it. So most of you, if I were to give you this, y is equal to negative 2x plus 5, and I were to tell you find y when x is equal to 1, you would not have any problem with that. You would not have problems with the directions, but when you're getting used to the new notation, you do need to get used to the way problems are phrased and how you might see that question. Simply substitute 1 for every x and then evaluate using order of operations. So instead of doing what I did on the right, you would probably do it this way. You would write f of x is equal to negative 2x plus 5. And then if you are asked for f of 1, you would plug in a 1 everywhere you have an x. And then you are simply evaluating. Negative 2 times 1 is negative 2, and then negative 2 plus 5 is positive 3. So your final answer would be f of 1 is equal to 3. What that means is that when x is equal to 1, the y value that goes with it is 3, or the 0.13 is on your graph, which is a little bit more helpful than just saying y is equal to 3. So for practice, I want you to find f of negative 4 when f of x is equal to the absolute value of x. So pause the video if you need to, and go ahead and work that out. Okay, so we're going to plug in a -4 everywhere we see an x. So f of -4. Well, what is the absolute value of -4? Absolute value means the distance from 0 on the number line. Something that we're not going to do as much of this year is absolute value equations and inequalities. We might hit that a little bit to review for your final because it might be a question or two on your final, but it's not mission critical to Algebra 2. So distance from 0. So if you are looking at the number line and then you look down here at the -4, and you were asked how far away are you from the 0? Well, you are 4 units away. And so the absolute value of -4 is 4. And if you were to graph that, it would mean when x is -4, y is 4. All right, so I do want to look a little bit at absolute value functions. The Unit 1 does have some absolute value stuff in here, including some equation solving and such. So we might take a look at that in another lesson. Not sure at this point. So now the X column probably looks okay to you. Now in the Y column here, I did want to put a couple different things here just so you get used to seeing them. So sometimes you'll just see a y. Sometimes instead of y, you'll see f of x instead, okay? And sometimes you'll see the expression like for the equation. And so, yeah. So what we would do to do this, and we won't do all of this out, but to find the y value, we're going to plug in -3 for the x. So the first one, the absolute value of -3 is 3. And so we end up with the 3. That's a terrible 3. 3, there we go. Now I can repeat this like the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0, okay, like how far away from 0 is 0? Well, 0. Now, here's where there is sometimes a misconception. The absolute value of 1, remember, it's the distance from 0. So the distance from 0 of 1 is just 1. Once in a while, I will get students, and usually I get a couple every single year. So that means that probably in the year that you're watching this, someone is going to have this misconception where they think that absolute value flips the sign. No, it is how far away from 0 are you? That's what absolute value is. Does it mean that sometimes the sign flips? Yes, but not all the time, because that's not what you're doing. It just sometimes that happens. So the absolute value of a positive number is still positive. Now, what you also might have heard, depending on how much you've studied absolute value, is you might have heard the absolute value is always positive. No, not quite, because 0 is not a positive number. And so you can't say the absolute value is always positive because right there, it is not positive. What you can say is that it's non-negative. Like it is never going to be negative because 0 isn't that either. All right, let's take a look at what this looks like. So we have -3 maps to a +3. We have -2 maps to a +2. -1 maps to a +1. Notice that this does appear to be a line. 0, 0. Then it turns around. Okay, so we got this like nice line coming down here. Well, not really. Let's try again. We have this nice line coming down, and now it's about to, it could keep going that way, because remember, you can pick anything you want. Now it's about to go the other direction, though. So 1, 1. So the number 1 maps to 1, which gives us a point right there. 2 maps to 2, and 3 maps to 3. And what we end up with is this V-shaped graph. So absolute value is usually known as our V-shaped graph. This is a great graph for teaching what are called transformations, but we are going to bump that into Unit 2 this year and come back and revisit it with multiple families of functions, although you are going to explore that on your homework a little bit. So that is what absolute value looks like. Oh, I missed a blank here. The parent function is this. It is f of x is equal to the absolute value of x. When we talk about a parent function, what it is the simplest function that belongs to that category or family of functions. That's what it is. It's just the simplest one. So the simplest absolute value function you can get is just y equals the absolute value of x. And that graph is known as the parent graph. Okay, it's like the simplest one, and it's like our home base for all the other stuff that we might do with it. All right, last little piece of this is Desmos. So Desmos and functions. And I'm gonna need to scroll down. So I just want to show you a couple things about how Desmos works. And as I mentioned in a previous video, once in a while, students will tell me that this part does not record. So they can hear me talking, but they can't see anything that I'm doing. If that happens, please let me know so that I can re-record this in a different way. Just this part, not the entire lesson, but just this part so that you can see it. So Desmos can switch between equations. You can enter your equations as both y equals and f of x equals. So if I wanted to do y equals, say, 2x, it will graph that, but I could also, instead of y, type in f of x is equal to 2x. So Desmos will recognize both of those, and I usually just tell students whatever is more comfortable for you. Now, to type an absolute value, there are a couple different ways that you could do this. Okay, I want to check and see. There's actually 3 different ways that you could do it. One way is underneath the backspace key on your keyboard and right above the enter key on your keyboard. So right in there, you will see a key, and it's got a vertical line as the secondary function. So you can hit shift and then that key, and it will open up absolute value for you. Okay, and you'll notice that that is exactly the same graph that we just did by hand by constructing a table and plotting points. Now, another way that you can do absolute value is if you click down here on the keyboard, you will see that absolute value is one of your options. And so you can type it in that way. The other option that you have is to type the letters A, B, S. And oh gosh, I almost said like Fusion, not Fusion. That's a totally different class. Desmos will register that as an absolute value symbol. So whatever is easiest, I would recommend that you kind of practice with both of them. The function keyboard is great, but it also it also will take you a little bit more time. So generally, if there is a keyboard shortcut, like we'd like to use it. So there's our graph. Now on your homework, just so you know, what I'm going to have you do is play around with this in specific ways, and I want you to notice how the graph moves. Okay, so that's like kind of a hint for your homework, like how the graph moves. Now you can do a couple other things with this. When you click on this, and then click, on that. Okay, so we're going to click on that, and then we're going to click on the little gear here where it says Edit List. One of the things you can do there is create a table. So I mentioned that we have 3 main ways of like talking about functions. We have the equation, which I have there in that top line. We have the graph, which you can see over to the right. And then we have create table. And what Desmos will do is it will generate a table for you from that particular function. And it will show you those points. Now you can also edit the table. So if I edit it and put in, say, -7, it will like update the table for me. which is kind of nice. If you put stuff in your table, so let's do like -20, we'll notice that -20 took my point off the screen. This little magnifying glass, zoom fit, will adjust your window so that you can see all of your points. You can also enter tables in yourself. So if you had a table that you wanted to enter, you can enter the plus sign, click on the plus sign, and then click table, and then enter your ordered pairs for whatever your function is. So I did want to make sure that we took a look at that. Okay, so you can use y or f of x. Okay, and then you can mess around with your equation and kind of explore, which is what I'm going to ask you to do. And then you can generate a table from that. Okay, so really, really useful stuff on Desmos, and I absolutely want you practicing with it. Now, here's our outline of Algebra 2. I mentioned at the beginning of this lesson that at the end, I was going to kind of take you through the entire course. So as it stands, as of the recording of this video, we have 7 units. Algebra 2 is built around the study of functions, and we study them in groups that share common traits. So Unit 1, which we typically can cover in August, is linear functions, and then we're going to introduce a little bit of absolute value. It used to cover all the absolute value, but making a call this year, we're going to try to weave that absolute value in throughout the year. Units 2 and 3, which cover most of the fall, are quadratic functions. We actually spend a unit on graphing them and analyzing their graphs and the behavior of the graphs. And then we have a whole unit on solving equations, solving quadratic equations, lots and lots of factoring, and that takes us like September to November. Polynomial functions is unit 4, and that will take like the end of November through December. This past year, we were able to finish that with just enough time to review for a midterm. So the goal is really to cover 2 units each quarter. So quarter 1, we try to cover units 1 and 2, maybe get into 3 because unit 1 is really short and unit 4 isn't really short. And then in quarter 2, we would do units 3 and 4 and then review and have your midterm. Coming back after the break, radical functions take up January and February, and we also get a little bit into how to solve those equations and expand on what you already know. February through March is a critical unit. That is exponential and logarithmic functions. That's really, really important to pre-calculus. Also my absolute favorite unit that we teach all year. And then unit 7 is rational functions. We'll cover that in April, probably the end of March, early April, depending on how well we can pace that. And then we do have to give our EOC fairly early before the end of the year because we try to front load our district EOCs. And so we can really only cover 3 units in the spring. After your EOC, we're going to circle back to some of the stuff that we missed or give you some prep for pre-cal. For your homework, not too many questions. Question 1 is the following relation a function. Tell me yes, tell me no. Be prepared to explain why. For question 2, graph each of the following on Desmos and state whether it's a function. You're going to be looking for that vertical line test. So you're going to type in each of those equations and see what you get. Okay, so tell me whether or not it is a function, yes or no. No work required to be shown for the first 2 questions. For question 3, f of x is equal to x to the third plus 2x. What is f of 2? You're going to plug in that 2 and evaluate. I do want to see all your work for that. And then the same for question 4. I didn't renumber it. I put in an extra 4. Okay, for the first question 4, it's evaluation. For the second question 4, I still have to remember to edit this. But it's an explore. So I want you to graph f of x equals the absolute value of x on Desmos, and then graph each of the following. And I suggest doing them one at a time because if you put all of them on there, it's going to be a very confusing, cluttered graph. So look at the first one, y equals the absolute value of x minus 4, and make a little note like what happened when you did that. And as a hint, the graph moved up, the graph moved down, the graph moved left, the graph moved right. and how far did it move. Then replace the 4 with a 7 and then see what happens. Then replace the 7 with a positive 3. So you're going to do plus 3 and see what happens. And then do positive 5. And then explain in your own words what you think adding or subtracting a number inside the absolute value does. After you look at all 4 of those, you should be able to say something. Question number 5 is the same thing, except instead of doing the subtracting and the adding inside the absolute value, now you've got them outside. So you're going to close out the absolute value and then subtract 4 and subtract 7 and add 3 and add 5. And then explain in your own words what you think adding or subtracting a number outside the absolute value does. And question 6, this should be familiar to you. Of the problems you answered, which would you like to review as a class? Do not write down problems that you skipped. So I'm sorry this video is really long, but there was a lot of content in there, and hopefully it was beneficial to you and you are equipped to do your homework assignment. Let me know if you have questions.